Hello everyone. So welcome to one more video in which we are looking at the problems with application of KVL and KCL. Okay, so again this is a problem with explained in text. So it helps if you draw the circuit diagram. So have a look at this question, and you can pause the video now. Have a look at this question. Try to answer it yourself, and then later on you can compare your answer with my answer to check your understanding. Okay, so let me just move down so that you can see the complete question. So this is the question. Okay, so now let me start working out this question. Okay, so what is this question about? So two resistors of values 2 kilo ohm and 5 kilo ohm are connected across in series a voltage supply of 100 volts constant. Okay, so it's a simple circuit. So let me draw that. So there is a 2 kilo ohm. So two circuits. Okay, so one is 2 kilo ohm and other is 5 kilo ohms, and they are connected across a voltage of 100 volts. Okay, so now I simply solve the A part. Okay, what is the A part? Find the true value of the voltage across 2 kilo ohm resistance without the voltmeter. That is fairly simple. Simply I can do the voltage division principle. So V1, let's call it V1 equal to 100 multiplied by 2 divided by 7. Okay, so this one, so it's going to be a decimal number. 100 multiplied by 2 divided by 7, so 28.571. Okay, so 28.57 volts. Okay, so this is the actual voltage that is supposed to come. Okay, so now in the part B, what we have done is connected a voltmeter. Okay, so the voltmeter itself is having an internal resistance of 20 kilo ohm. Okay, and this is my voltmeter. Okay, so as a result, the net total resistance will change. Okay, so what is the resistance here? R, let's call it R1. So 2 into 20 divided by, so by the way, this is all in kilo ohms. Okay, so kilo means 1000. So this 2 will get cancelled. So it will be 28.57 volts. So here also 2 kilo into 20 kilo by 2 plus 20. So this is also in kilo. So it will get cancelled. So I'll get like this, 2 into 20 divided by 22. So 1.1818 or 1.8181 ohms. Okay, so this is the effective resistance here. Now this resistance will get will be in series with 5 kilo ohms resistance. Okay, so this is kilo ohms, sorry. So here in the numerator 2 kilos are product and down 1 kilo is there, so only 1 kilo will remain. So it is like this. So now the effective resistance will be 1.8181 plus 5. Okay, so now therefore V2, that is whatever the voltmeter will measure, will be something like this. It will be 100 multiplied by 1.8181 divided by 1.8181 plus 5. Okay, so what is that? So 100 multiplied by 1.818181 divided by, now here 6.818181. Okay, so 6.818181. So I'm getting 26.666. Okay, so 26.67 volts. Okay, so the actual voltage, real voltage is 28.57, but it is reduced to 26.67 volts. Okay, so that is the reduced voltage which is being measured. So this is the measured voltage, this is the true voltage. So there is an error here. Okay, we'll calculate the error, but look at part C. Okay, I'm sorry, this is B. So now come to part C, percentage change in the supply current. Okay, so what happened to the supply current? Now supply current, because the resistance has reduced, the supply current will change. Okay, so earlier the total current, so I1 is nothing but 100 by 7 kilo ohms. Okay, so whereas now I2 is nothing but 100 by 6.8181 kilo ohms. So there is a small change here. Okay, so let us see what is the change. So 100 divided by 7, so that will be 14.2857 milliamperes. Again, be careful with the unit. Okay, so here it is kilo ohms, so it will become milliamperes, whereas in this case it is 100 divided by 6.818181. Okay, so I'm getting 14.6667 milliamperes. So what is the change in the percentage change in the current? So so this is the true current. Okay, so actual I mean the measured minus true divided by true. Okay, so that is what we have to see. Percentage change is nothing but I2 minus I1 divided by I1 into 100 to get the percentage. Okay, so what is I2? So 14.6667 minus 14.2857 divided by 14.2857. So let's see what it is. So already I have this. So from this I will minus 14.2857 and then I will divide it by 14.2857. Okay, and I'm getting something like this 0.0266. So that is in percentage wise, if you multiply with 100, so I'll multiply with 100, so I'll get 2.666. So 2.667% increase in the current. Okay, so because of your measurement, 2% current is increasing. Okay, so that is also one of the concern. Whenever you are measuring something, the current will increase. Okay, because that is called the loading effect of the voltmeter. So remember, this is a voltmeter. Every voltmeter will have a resistance internal which will impact the measurement. It will introduce small percentage error. Anyway, now come to the final one. What is the percentage error in the measurement itself? Okay, so percentage error is measured minus true divided by true. Okay, so that is the equation. So what is the measured value? So measured value is 26.67 and the true value is 28.57. So divided by 28.57. Okay, so how much is that? 26.67 minus 28.57 divided by 28.57, and then this value I can multiply with 100 to get the percentage. Okay, minus 6.65%. Okay, so the error is about 6%, which in some cases it will be quite significant. So but in some cases it can be kind of ignored. Okay, so this is the issue. Now it happens, I mean this cannot be avoided. So the way only you can do is only to minimize the impact by having a high resistance voltmeter. So whenever you purchase a voltmeter, you can ask the question, what is the internal resistance of the voltmeter? If it is 20 kilo ohm, it is not good to measure like this. If it is like 1 mega ohm or like that, then it is good to measure. So now there is one more question here, that is repeat the problem A to D by interchanging the 2 kilo ohms and 5 kilo ohm resistance. So basically what now we have to do is get the 5 kilo ohm here and 2 kilo ohm here and then repeat the exercise. Now what do you think? So what do you think? The accuracy will improve or accuracy will be more worse? Okay, so I'm guessing, I mean you can make a guess, you can pause the video and guess it. Here the error is minus 6%. Will the error be more than 6? I mean, in magnitude wise, will it be close to 10% error? Will it be like that? Okay. So you can think about it, pause the video and think about it. And now my guess is that if you keep the 5 kilo ohm resistance here and 2 kilo ohm resistance here, the error will be more severe. Okay. So because 5 and this 20 are more close to each other, the impact on the circuit will be more severe and the error will be more severe. So, but I leave it to the viewer to try that, take a sheet of paper and then interchange this 5 and 2 and repeat these calculations, and then see for yourself whether the error is increasing or decreasing. And if my conclusion is correct, or if my conclusion may be wrong, whatever it is, you can share your findings in the comment section. So that's it. We will stop this video here. In fact, I am doing this playlist on KCL and KVL. So for the time being, I will stop it here. Maybe in future I will add more videos to this playlist. But as of now, I'll keep this playlist here. I hope you got a good flavor of different problems that we solved in the previous videos in this playlist, and different ways in which you can use the KVL and KCL to understand, to get the impact on different parameters in the circuit. So with this, I will stop here, and look at any textbook in electrical circuits. You will find literally hundreds of problems you will find. So please pick up any electrical engineering textbook, basic electrical engineering textbook. For example, I am using BL Tereja, Electrical Technology Volume 1 by BL Tereja. So if you search with this name online, you will find the free PDF also. So you can download, go through the relevant chapter where this simple KVL KCL is discussed. You will find several example problems, and you can try yourself, not only limited to this particular playlist, but try your own problems. And if you find any particularly interesting, particularly tricky problem, please do share the problem with me via your comment section, so that I can try and make a video on that. So I hope this is fine. So let's see you in the next playlist. Thank you.